Hi guys, today we're going to be looking at a question on electromagnetics. A simplified diagram of an electric generator is shown below. When the coil is rotated at a constant speed, an EMF is induced in the coil. Question 9.1.1. Is this an AC generator or a DC generator? As we can see in the diagram, there's only a split ring commutator and not slip rings. Therefore, we know that this is a DC generator. Question 9.1.2. Briefly explain how an EMF is generated in the coil when the coil is rotated by referring to the principle of electromagnetic induction. So, in a generator, an EMF is induced as a result of the change in the magnetic fields or the magnetic flux, which is linked to the coil. Question 9.1.3. Draw a sketch graph of the output voltage versus time for this generator. Show one complete cycle. So as we can see, this coil is sort of horizontal. So you would start at the origin. However, you could start on the y-axis somewhere up here and start from there. Either one is fine, but I'm going to start from the origin. And since it's a DC generator, it's only positive and above the x-axis. So for a complete cycle, we would have two waves or two rotations. Well, one complete rotation, but this is going up and then down. Question 9.2. A 200 ohm resistor is connected to a DC voltage supply as shown in diagram A. The energy dissipated in the resistor in 10 seconds is 500 joules. The same resistor is now connected to an AC source, diagram B, and 500 joules of energy is also dissipated in the resistor in 10 seconds. Question 9.2.1. Define the term RMS voltage of an AC source. The AC RMS being the potential difference, which dissipates the same amount of energy as a DC potential difference. That's what the term RMS voltage means. Question 9.2.2. Calculate the maximum voltage of the AC source. To calculate the maximum, we have the work, we have the voltage, and we have the resistance, as well as the time. So we can use the equation W is equal to V squared over R delta T. If we plug in all our values, we get V squared to be equal to 10,000 volts. Therefore, V, which is also equal to VRMS, is equal to 100 volts. We can then say that VRMS is equal to Vmax over root 2. And we know that the RMS is 100. We want to calculate Vmax and over root 2. We then get Vmax to be equal to 141.42 volts. And that's all for this video. Thank you.